yesterday we learned slope y-intercept form of a line, so y equals mx plus b. Today we're going to learn another form of an equation of a line. Still an equation of a line, just a different way of expressing it, and an easier way if we don't know what the y-intercept is, right? Sometimes the line doesn't go through a nice value on the y-axis. So if we don't know what it is, this will help us. Okay, so first questions there. I want you to state the equation of each of the following in slope-intercept form. So yesterday's work. Look for the y-intercept, figure out what the slope is, and then come up with the equation in that form. Remember, y equals, so slope-intercept form, oops, that's messy, is y equals mx plus b. Okay, so you want to find the slope and the y-intercept. Basically a review from the last section. Find the slope and the y-intercept. I don't know what you're asking. Negative 1x. So remember, we talked about slope-intercept form. It's kind of the easiest form if we can find the y-intercept. So this one's nice because it's at 3, right? So b is 3, and the slope, find 2 nice points. Notice how the x-intercept isn't nice. So find another one that has a nice grid crossing like that. That's at negative 3, negative 1. So to form your triangle, you're going up 1, 2, 3, 4, to the right 2, which simplifies to 2. You could have done a different triangle, a larger one or a smaller one, but you should still get a slope of 2, so that's 2x plus 3. Now you have the equation. Now you can find any point on that line, even beyond the grid. Okay, do the same for the next one. Y-intercept looks like it's at a nice number. Choose another point, find the slope. Okay, so that looks like it's at 1. A little bit hard to tell. Looks like here is a good point at a grid crossing. Okay, and so if I draw my triangle there, it's down 1, 2, 3, 4, to the right 3. So my slope is negative 4 over 3. My y-intercept is 1. So y equals negative 4 thirds x plus 1. Okay. Take a look at the next one. What's hard about the next one? Will? The y-intercept. You kind of have to guess, right? In a sense. And with these equations, we don't want to have to guess. So that's why we're going to learn this new form of the equation of a line. Like this is a nice number, right? A nice intercept, it's 5, but that doesn't help us. There isn't a form called the x-intercept form. So this we would have to estimate. So here, from what we know, we would estimate it to be y equals, well, choose another. So here, that's a decent point. So that's up 1 to the right 4. So I would estimate it as 1/4 x minus, say, 1 1/4, minus 5/4 maybe. In equations of lines, we like to use fractions, or we need to use fractions, unless you're told it's okay to use a decimal. So default settings basically is fractions in lowest terms, okay, improper fractions. So I'm guessing Maybe it's negative 1⅓. Kind of hard to tell, right? So that's where we're going to learn the next step. So it says it was easy to find the equations for 1a and b because the slope and y-intercept were easy to identify. Where, should be were you able to write an equation for the graph in 1c? Well, yes, but we had to estimate. The y-intercept. So when writing equations of lines, we cannot assume the values of points. That's what we had to do. We have to use exact values. We could find the equation of a line when the y-intercept is unknown by substituting another point into y equals mx plus b and solving for b. So let's do it that way, okay? So here we know the slope was 1/4. We didn't have to estimate that, okay? But we didn't know for sure what b was. So we're going to leave it as b and then choose another point. Okay, so we use this point to help us get our slope. So that was 1, -1. So I'm going to use that to find my value. Oops, 1, -1, not -1. I'm going to substitute that into my equation because every point on that line has to satisfy the equation. So when I put -1 in for y, 1 in for x, I can solve for b so that that point is on the line. So if we do that, that's -1 equals 1/4 b plus b. So b, I would subtract 1/4 from both sides. So -1 minus 1/4 as an improper fraction is -5/4. Turns out that I estimated well. So I estimated it to be -1⅓, which is -5/4. I was lucky. Maybe I might have said -1⅓, and then I would have been off. But it turns out that that's what it is. Okay, so that's always a way that you can get the equation of a line. If it's not a nice y-intercept, you can substitute another point in and solve for b. Okay, so again, we haven't learned a new form of the equation yet. That's another method that we can use. Sometimes that's a little, takes a little bit of time to do that. We want something that's pretty convenient, and that's the slope point form. So in order to write the equation of a linear function, we need the slope and a point. When we're not given the y-intercept, solving for b can be time-consuming in order to write our equation in slope-intercept form. There must be another way, and there is. So slope point form of an equation of a linear function starts from the slope formula. Okay, any point on the line has coordinates x, y. So that's our general point. That's every point on the line, coordinates x and y. And then a specific point we call x1, y1, just like we do in the slope formula. So there's our slope formula. Now this is going to be our point 1. Makes sense. It's got a subscript of 1. This is going to be our general point that we're going to call point 2. So if we put in point 2 and point 1 in here, then it's going to be y, no subscript, just y minus y1 over x minus x1. Okay. Then it says rearrange the equation using cross multiplication. So remember, to do that, we multiply across the equal sign. So when I do that, 1 times y minus y1 is just y minus y1. And then we'll have m bracket x minus x1. So that's just cross-multiplying the slope formula with a general point xy. And that's it. That's your slope point form. Okay? So you need a slope and you need a point. You substitute those in and you've got the equation of a line. Okay? Done. So it's pretty easy. If you know the y-intercept and the slope, you put them into y equals mx plus b. If you know a point that's maybe not the y-intercept and the slope, you put it into this formula. You're done. Okay? The only time you're not done is if you're asked to show it in what's called general form, or to rearrange that to slope-intercept form. But that's just rearranging an equation, and that's pretty straightforward. Once you get practicing it, you'll see what happens. So that's what we'll do in the next part. Here it just summarizes that formula. Now, I'm going to hand out a formula sheet for you today that you can keep in your binder. There's not many formulas on it. There's the slope formula, which we already gave you on the last test. This test will probably just give you the formula sheet because it has that, and then it has all the 3 types of equations of lines. Okay, plus some measurement formulas that you'll use later on in the course. So this form is mostly used when the y-intercept is not known, so that we don't have to put it in slope-intercept form and solve for b. And mostly used when the precise value of the y-intercept, oh, sorry, that's what I just said. Yeah. And you cannot find it from a graph. So either of these situations, just written out or from a graph. All right, so let's practice. Let me keep it up there. So here, write the equation of a line that passes through this point and has slope 2/3. So this is your x1, y1. So your equation is y minus -4 equals the slope 2/3 bracket x minus 3, which is x1. And then we just always show without 2 brackets. So if you can do that in your head, that y minus -4 is y plus 4, you can just go right to that final answer. That's your equation of the line in slope point form. Done. Okay, no work really needed. X-intercept of -5. Well, x-intercept doesn't help us in terms of like a special form. Just find the coordinates of the x-intercept. That means the y value is 0. Okay, so in terms of the equation, y minus 0 equals 1/4 bracket x minus -5, which is like adding 5. And we don't have to show the -0. Y minus 0 is just y. So if you can do that in your head, go for it. It's just 1 mark, right, to do that. 1 step. Passes through this point, slope of this. So y minus -6 equals slope bracket x minus 1. So y plus 6 equals -5/2 bracket x minus 1. Done. Okay. Then it says graph the line from part A on the grid. So it says passing through the point 3, -4. So we did this in the work last week, right? So you plot 3, -4, slope of 2/3, go up 2 to the right 3. If you run out of grid space, then go the other way. So slope of 2/3, remember, is the same as -2 over -3. We never leave it with a negative over negative because it's not in simplest form. But for graphing, we can go down 2 to the left 3. Just try to fill up as much of your grid as you can. Okay, then join those up. I'll do blue. Okay, and put arrows on the end. So the test that you just wrote, I wasn't picky about having arrows on the lines for that test. For this test, I will be picky. Okay, so straight line, so get a ruler, a straight edge, invest in one for the rest of your math career, and then put arrows on the end. So here, that's what I'm going to be looking for because it goes on forever. Okay, oops, that didn't look like that. That's not what I meant to do. Yeah, I forgot to, I was still in line mode. Okay, there we go. Okay, now we want to compare. It says convert the equation from line A into slope y-intercept form. So I'm just going to copy it out. We had y plus 4 equals 2/3 bracket x minus 3. That's the equation. We now want to convert it to slope y-intercept form. So if you're given this, that means you want to solve for y and don't have any brackets. So I'm going to get rid of my brackets first by distributing the 2/3. This works out nicely because 2/3 times -3 is -2, so subtract 2. And then, so we distribute that, and then we subtract 4 from both sides. Notice how the slope doesn't change. The slope is not going to change. The same line, doesn't matter what form of the equation, the slope needs to be the same, and it is. And then the y-intercept would be -6. Okay? Verify looking at our graph, so that this is saying that that equation should have a y-intercept of 6. Well, let's look. I'm sorry, -6. What's the y-intercept? It's -6. Okay? You know you've done it correctly. So it's just a different way of showing the equation. It's an easier way. If, like this one would be obviously easy to find the equation in slope-intercept form because it had a nice y-intercept. They just don't always do. Hi, what's up? Johnny. No.
No, all right, thank you.
Okay, so let's take a look here for question 4. For each equation, state the slope and the coordinates of a point. Sketch the graph. Label with its appropriate letter. Some of you on the last test didn't label your lines. Okay, so maybe what line I thought it was wasn't. So I took the benefit of the doubt, but you need to label them if you're asked to. Okay, take a look at the form. It's y minus a number here equals a number outside of the brackets. Might try, I guess you could have a coefficient in front of the x. That technically wouldn't be in point slope form, but I don't think we're going to try to trick you at this point. But as you go on in math, you need to be careful about that. So this is in perfectly good point slope form or slope point form. So the -3 is the slope and a point on the line. Remember how we subtracted? So it was always the opposite sign. So here, back up to these ones, the point was 3, -4. So here in the x, it was x minus 3. The 3 makes that bracket 0. The -4 makes this left side 0. So that's how you can tell what it's going to be. So here it's going to be -5 for x and +4 for y. Opposite signs of those constant terms. Okay, if we graph that, then we plot -5, 4. Always have to start from a point. And the slope is -3, which is -3/1. So down 3 to the right 1, down 3 to the right 1. So we can get quite a few points here to fill up our graph. We could also go +3/1. Okay, so 1, 2, 3 to the left 1 and fill up our grid. Okay, pretty close there. Just going to go there. Okay, and then arrows on the end. And that is line A. Okay. Let's do red for the next one. Okay, again, point slope form. So the slope is 2/5. And the point, you look at the x value that makes that 0, that's +1. Y value that makes this 0 is -6. So 1, -6. And your slope is positive, so it's going up and to the right. So up to the right 5. Or I've run out of space, so I could go down to the left 5, a negative over a negative. Okay, and you work on the last 2. Okay, so those are the equations of the lines. You'll be expected to graph those for the next test. So things to remember that I'm going to look for: straight lines, so get a straight edge, and arrows on the end. So because I was very lenient on this past test, but not for this coming one. Okay, now if it says line segment, what does that mean compared to a line? It's not infinite. So it ends at 2 points, right? So you wouldn't put arrows, okay? Well, yeah, then it would be, yeah. So I'm just going to be picky in general about what you're supposed to be graphing. Seth, can you be part? Okay, so question 5 on the next page. So another thing to graph. So on the grid, draw the line with slope -3/2, passes through -2, 7. So you need to be good at this. Okay, so plot it. Plot it. Plot, yes, P-L-O-T. Plot the line. Plot the points. Join them up. Boom. Good. Okay, so there's the line. It says state the equation of this line using the slope and point -2, 7. So, and it says to express it in this form. We could use slope-intercept form really easily because the y-intercept is a nice number, right? It's an integer value. But it says this form. So you can use 0.04. So if I do, then that would be y minus 4 equals the slope, which is -3/2. Oh, sorry. Actually, let's use the point that was actually given to us. Yeah, I know. Sorry, I was skipping ahead in my head. Okay, so y minus 7 equals -3/2 x plus 2. Okay, so -2, 7 was up here. We didn't need the graph, right? If we were given a point and the slope, we can just come up with the equation. Then it says convert your answer into slope y-intercept form. Okay, so that means first step is I get rid of the brackets by expanding out distributive property. And this is nice as well because -3/2 times +2 is -3. So it's just subtract 3. Okay. Now I need to get y by itself, so I'm going to add 7 to both sides. Okay, and that's going to confirm that our y-intercept is 4. Okay, so it says state the y-intercept. So y-intercept equals 4, and can verify on your graph. Well, we can see it right there. Okay. Then it says state the coordinates of one other point on the line besides the y-intercept. I've plotted quite a few. I'm going to choose maybe this one, 4, -2. Okay, so 4, -2. Some of you, when you're giving me coordinates of points, you're not putting the round brackets around them. An ordered pair has the x value and the y value with round brackets. So make sure your mathematical form is correct. Okay, state the equation of this line using the slope and this point in slope point form. So same thing as before, y minus -2. So do that in your head. Y minus -2 is y plus 2. The slope is -3/2. Oops, that looks funny. Bracket x minus 4. Guys, can you stop? Okay, so we've done it in slope point form with a different point. Now convert that into slope y-intercept form. What do you think? Should it be the same? Yes, it should. It's the same line. We used a different point. We have the same slope. When we expand this out, and again, distributive property works out nicely. -3/2 times -4 is +6. We're going to subtract 2 from both sides. So you can see that you get y equals -3/2x plus 4. Same. Right? Same. All right? Same. Oh, we have to do H. Okay? And so, to summarize, it says in general, listening please, in general, the equation might look different when it is written in slope point form, depending on what point you use. So you might use a different point than me, but if they're on the same line, then you should get the same equation because the slope should be the same. When converted to slope y-intercept form, it should look exactly the same. So does the point 16, -19 lie on this line? Justify your answer. So here's the proper way of verifying. Oh, Last question again, does. Okay, so here's the proper way. You do a chart. Okay, left side, right side. So a lot of you will just put the coordinates in and you'll keep the equal sign and then you find out maybe that they're not equal. And so you're making a statement that doesn't make sense. So I separate it because it seems the easiest way to keep the left side separate from the right side into what I call a T chart. It's a big T. The equation that I'm checking is this one here, right? I'm just going to use the slope-intercept form. And so my y value, which is on the left side, is negative 19. On the right side, I have negative 3 over 2 times the x value, which is 16, plus 4. Oops, I just... Okay, so negative 19, there's nothing to do to that. Negative 3 over 2 times 16 is, 2 goes into 16, 8 times 3 is 24, so negative 24 plus 4 is negative 20. It's close to being the same, but it's not. So then I say left side is not equal to the right side, therefore the point is not on the line. Yep. Okay, 3 dots in a triangle shape means therefore. Therefore, the point is not on the line. Okay, so that's how you can verify and not state that they're sort of equal when they're not. Okay, that's where we're going to leave it today, but that doesn't mean that you don't have homework. You can do most of the work, well, all of it actually, so you can start, you can do the practice, because there's just a few questions left, but really we've done everything. The only thing in question 5 on the next page is that you have to calculate the slope first. The line's not, the graph isn't given to you, and so you have to use the slope formula. But otherwise, you can do everything. So please do homework this weekend, because notice that some or many of you are not doing all of